So in this video, we are going to talk about trigonometric functions. So it's basically trigonometry review. So I'm actually going to put all these three chapters together. We're not going to go through everything in chapter 5, 6, and 7. We're only going to talk about the highlights because you've covered this already in Math 104 and in your trigonometry class. So I'm not going to spend a lot of time with the review. I'm going to talk about the basics and some of the more complicated problems. If there's a question, just let me know. I will. This is mainly for your review because I know that it's been a while. We've been talking about algebra a lot, and we haven't really been talking about trig. So we've been talking about different types of functions. We just finished exponential and logarithmic functions, and now we're going to look at the trigonometric functions and then and more application stuff. So the first thing to kind of remember, I guess, is the unit circle and right triangle trigonometry. So we'll start off with the right triangle trigonometry first. So right triangle trigonometry. And if you ever have any questions about certain specifics of trigonometry, I'm teaching trigonometry right now. So I have a couple videos that you can go ahead and watch in case you ever forget. So some of the things to kind of remember from right triangle trig is that you have a right triangle, and later on we'll talk about things that are not right triangles. And then you have an angle theta. Now this angle theta can be anything. So here this funky looking sign is called theta. You have another ways that we can express angles. So you have this thing called phi or phi. You also have something called alpha. You have beta. You have gamma. So all of these Greek letters are usually used to indicate angles. Okay, you usually see them a lot. You use them in stats also. So one of the things that you want to be able to do is figure out all the trigonometric functions. So for example, if I say that this is 3 and this is 4, then we can try to figure out the sine, cosine, tangent, cosecant, secant, and cotangent. So that's what we want to do. So what would be the sine of theta? What would be the cosine of theta? What would be the tangent of theta? The cosecant of theta? The secant of theta, and the cotangent of theta. So that's what we want to be able to solve. So the first thing that we want to be able to think about is, well, we need to figure out what this side is. So in order to find that side, we have to use the Pythagorean theorem. So we have 3 squared. So remember, a squared plus b squared equals c squared. So you got 3 squared plus b squared equals 4 squared. This 3 squared is going to give me a 9 plus b squared equals 16. I'm going to subtract the 9 over. So I get b squared is equal to 16 minus 9. 6, 7, 8, 9. That's going to give me 7. I'm going to take the square root to both sides. But remember, when I take the square root, I put plus or minus. Now, in this case, it doesn't matter to put the plus or minus because it should be a positive square root of 7. Because the triangle should have a positive length. Now, when we get to a triangle in a quadrant plane, then it can be negative. So one of the things that you can remember from right triangle trigonometry is the acronym SOHCAHTOA. Okay, so we have this SOHCAHTOA. Remember that SO just means sine is opposite over hypotenuse. Cosine is cos adjacent over hypotenuse. TOA is tangent, is opposite over adjacent. So remember that your opposite side is always going to be opposite to your angle theta, which is going to be that. That's your opposite. This is going to be your adjacent. It's always a 1 right next to it. And your longest side is going to be your hypotenuse. So here, sine is going to be your opposite over hypotenuse. So that's going to be the square root of 7 over 4. Your cosine is going to be the adjacent over the hypotenuse. That's going to be 3 over 4. And then the tangent is going to be the opposite over the adjacent, which is going to be square root of 7 over 3. Okay. Now, what about cosecant, secant, and cotangent? Well, cosecant is just basically 1 over sine of theta. Secant is 1 over cosine of theta. And cotangent is 1 over tangent of theta. So if you kind of think about it, if I know what the sine, cosine, and tangent is, the reciprocal of that, or flipping it, is going to be the cosecant, secant, and cotangent. So square root of 7 over 4, that's going to be 4 over square root of 7. If I rationalize this, this will be 4 square root of 7 over 7. The cosine is going to be 4 over 3. The secant is going to be 4 over 3. And then the tangent, the cotangent is going to be 3 over square root of 7, which is going to give me 3 square root of 7 over 7. Okay. So hopefully this is just review. You can feel free to write all of this out if you want to, or you can just watch if you want to, just to remember. One of the things that you have to remember about right triangle trigonometry is also the acronyms. So for example, you have all students take calculus, okay? ASTC, which basically means all students take calculus. This just means if you have, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So basically what this means is that it tells you where all of the functions are positive or negative. So here it tells you positive. So here all of them are positive, all trig functions. Here in quadrant 2, sine is positive. Okay. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. So that should also include their reciprocals. So here, the reciprocal of sine is cosecant, so cosecant also is positive here. The reciprocal of tangent is cotangent, so that one's also positive there. The reciprocal of cosine is going to be secant, so that's also positive there. Okay, and why is that useful? Well, one of the things that we can do is we can actually put all of these different things in a coordinate plane. Okay, and the way that we can draw triangles in the coordinate plane, it kind of has a resemblance of a bow. So if I think about this being a bow, you can kind of see the right triangles there. So here are my right triangles. So if my right triangle is in quadrant 1, 2, 3, or 4, we know how to draw the triangles. It's basically just hugging the x-axis. Okay? So let me give you an example. So let's say, suppose that cosecant of theta is equal to 3. And tangent of theta is less than 0. Find the other trig functions. Okay, so we have a couple of things here. So first, we are given some information. We are given that cosecant of theta is equal to 3. And we're also given that tangent of theta is less than 0. Okay, cosecant is positive. This tells me that tangent is negative. So in what quadrant am I in? So remember, cosecant is positive. That means it's right here, or it can be right here. But since tangent is negative, that means it has to be in quadrant 2. So when I draw my triangle, the base is going to be hugging the x-axis. It's going to be right on it. Okay, so here is my angle theta. So now what we want to think about is, okay, cosecant. Cosecant is the opposite of sine. Sine is opposite over hypotenuse. So this 3 is hypotenuse over opposite. So this should be 3. And then this one should be just a 1. Okay. How do we find out the other one? Well, let's just use a squared plus b squared equals c squared. A squared plus 1 squared equals 3 squared. So this is going to give me 1. This is going to give me a 9. So a squared equals 8. So a is equal to plus or minus. The square root of 8 is 2 square root of 2. Okay, now is it positive or negative? Well, in quadrant 2, we are on the negative x-axis, so this will be negative square root of 2 over 2. I'm sorry, negative 2 square root of 2. Okay, so that's what a is going to be. So now that we know that, we can figure out the rest of the trig functions. So we already know cosecant, so the sine of theta is going to be the opposite over the adjacent, which is 1/3. Or in other words, just flipping the cosecant. The cosine is going to be equal to the adjacent over the hypotenuse. That's going to be negative 2 square root of 2 over 3. Okay. The tangent of theta is going to be equal to the opposite over the adjacent, which is going to be 1 over negative 2 square root of 2. If I rationalize this, this is going to give me square root of 2 on the top, and you're going to have a negative 2. Square root of 2 times square root of 2 gives me square root of 4 times that, which gives me 2. So this is just square root of 2 over negative 4. Then we already know cosecant. Cosecant we don't care because we already have it. Secant of theta. Okay, secant of theta is going to be the hypotenuse over this guy, the adjacent. So we do the same thing by rationalizing it, and we're going to get 3 square root of 2 over negative 4. And then we have cotangent of theta. Cotangent is going to be the, since tangent is opposite over adjacent, then adjacent over opposite is going to be negative 2 square root of 2. That's going to be the cotangent. Okay. Now, some of the other things that you could have done is you could have just easily just used the trig identities. So remember these trig identities. So these you must know. So even if you are online or on campus or whatever, you should memorize these. Okay. So the first is the Pythagorean identities, which you love. Okay. The first one is sine squared theta plus cosine squared theta equals 1. Okay. So this is something that you just absolutely have to know. Okay. Also, cosine squared theta plus sine squared theta equals 1. Okay. Another one. So here's one that's one. The other one should be 1 plus tangent squared theta equals secant squared theta. That's another one that you have to know. And then 1 plus cotangent squared theta is equal to cosecant squared theta. That's another one that you have to know. The Pythagorean identities. The other ones are basically just basic. You know that tangent of theta is equal to sine over cosine. Cotangent of theta is equal to cosine over sine. We know that also cosecant of theta, we've already said that by the reciprocal identities is 1 over sine of theta. And then secant of theta is going to be equal to 1 over cosine. Okay. And similarly, we also know that tangent is equal to 1 over cotangent. Okay. And also cotangent is 1 over tangent. Okay. And so on and so forth. One of the things that I really want to make sure that you guys understand is that do not write this. I'm going to write it in red. Do not write tangent is equal to 3/5. This is wrong. If you write this on the exam, you are going to get this wrong. What you need to write is tangent of what? Of theta equals 3/5. So you need to make sure that you always write theta. If you don't, you're going to lose points because that's not right. Tangent and cotangent, cosecant, all the trig functions have an argument inside of it. It has an angle. So make sure that you always write this out. If you don't be lazy. Okay, because you will get docked points a lot in your calculus courses as well. So you need to make sure that you always discipline yourself by writing theta all throughout. Okay. Alrighty, so this is just some of the basics, okay? Obviously, remember that there's 2 different types of measurements, of angle measurements. So there's 2 of them. The first one is what we call radians. And the other ones, which are more familiar to you, are what we call degrees, okay? So between radians and degrees, we have in 360 degrees, there's basically 2 pi radians. Okay, so in addition to this, you should know the unit circle, or at least know how to derive it. And this is what the unit circle is. Click on it. So, oops, that there's a unit circle. You should know this circle either by heart. If you don't know it by heart, it's fine. You should know how to derive it. Okay, if you don't know how to derive it, please see me and I'll go ahead and explain how to do it. But you should feel very, very familiar with this, especially if you took a whole semester of trig. Then you should know it. If you've never taken trig, we need to talk because you will not be able to survive this. So do know how to do it. I'm not going to go ahead and explain it unless you really need to see it be derived. There's many different ways. There's on YouTube, there's many different ways you can memorize it or just find it out. In my trig videos, I show what the unit circle is and I explain it extensively, so you can look at that as well. But I have the expectation that most of you guys know what this is, know how to get angles. Remember that your x value Okay, so in this unit circle, your x value is basically your cosine of theta, and your y value is your sine of theta. Okay, so every x value is going to be your cosine, every y value is going to be your sine. And then be able to get tangent, cotangent, and all that other stuff. Okay, so if I ever tell you, what is the sine of 5 pi over 3? Well, what you're going to do, you're going to look at 5 pi over 3, which is right there. Okay, is the y value, so that's going to be equal to negative square root of 3 over 2. Okay, you also have your calculator, but I don't know if you're going to be allowed to use a calculator in future math classes. So make sure that you really know how to do this circle, okay, because it's really, really important. Okay,